Hello, ladies and gentlemen. Welcome to the WA2 review. Let's take a look at MCQ questions. For question 1, the MCQ answer is C. Answer A is wrong. The total momentum is actually 0. Answer B is wrong because of the word during. It should be before and after the impact. This is because it's an elastic collision, so the KE before and after the impact is conserved, not during. Okay. Next, what is the KE of the two objects? The KE of the two objects will be half mv squared plus half mv squared. This is the total KE is mv squared. So the mv before and after the impact is correct. Now next, the spheres will move off in the same direction will not be correct. Okay, so that question 1 is C. Let's take a look in question 2. Question 2, the answer will be D. All right, so the ball hits the wall at 30 meters per second, and then after that it rebounds from the wall also at 30 meters per second. So the change in velocity will be 60 meters per second. So the impulse under the graph, this is considered the impulse, will be equals to the rate to the change in the momentum of the ball. So let's find the impulse. All right, and the impulse is given by the area of a trapezium. So that would be half 6 plus 2, okay, multiplied by 10 to the power of minus 3 because of millisecond, multiplied by the height, which is the F max, and will be equals to the change in the momentum of the ball, which is 0.05 multiplied by 60. So solving this using a calculator, we get F max is equals to 750. Right, let's go to question 3. A body of mass m moves in a horizontal circle. So the momentum at this point, this is m, this is v. So the momentum at this point will be mv, and the momentum at this point will be minus mv. So the change in momentum will be like minus 2 mv. Now the work done by the centripetal force will be 0 because the speed is constant. So there is no change in the KE. Furthermore, it's a horizontal circle, so no change in GPE as well. Okay, so the work done is 0 and the change in momentum will be 2 mv. Now let's take a look at question 4. For simple harmonic motion, the kinetic energy of the object is given by half m omega squared x naught squared sine squared omega t. Now for the sine squared omega t, there are 2 humps per period. Okay, right, so the period here will be 0.4 seconds. Okay, so the KE is given by half m omega squared x naught squared. The amplitude is 0.0050 meters. So now that we've got all this information, what is the maximum acceleration of the particle? It turns out that we don't really need to do any calculations because the maximum acceleration of the particle will be omega squared x naught. Now we obtain from the period that is 0.4 seconds. So omega squared will be 2 pi divided by 0.4 squared. And then the value of x naught is 0.005 meters squared. So altogether, this will give us an answer of 1.23 meters per second squared. So this is all the excess information that is given to us. The only information that is required actually is the amplitude and the period. Now, question 5, the answer will be D. Which of the following contains quantities that remain constant when a particle goes undamped? Simple harmonic motion. So the variables in a simple harmonic motion will be displacement or x. We have velocity, acceleration, time, kinetic energy, and potential energy. Now, the constants in simple harmonic motion will be frequency, period, omega, x naught, and total energy. All right, so these are the ones that remain constant. The rest will change. Now let's take a look at question 6. For question 6, Newton's second law says that the rate of change of momentum is directly proportional to the resultant force acting on the body, and the change takes place in the same direction, in the direction of the resultant force. So what are some common mistakes that you make? So it is wrong if you state the equation F equals to ma, right? So this is one of the common one. And then it's wrong if you forget the word resultant, okay? And it's also wrong if you use the word equals to the rate of change of momentum. And of course, if you forget the direction, you also don't get the mark. Now let's take a look at question 6b. The ball is colliding with a fast-moving bus. So here is a bus that is moving towards a ball, all right? So when the ball and the bus collide, now the ball will exert a force on the bus, and then the bus will exert a force on the ball. And according to Newton's third law, the forces on the ball and the bus will be the same. So the ball and the bus experience forces which are equal in magnitude but opposite in direction due to Newton's third law. But however, the ball has a smaller mass, so the ball will experience a larger acceleration than the bus. The bus will continue moving in this direction, but the ball would actually change direction and move away. Okay, so that's 2 marks. Now, let's take a look at 6.1. Figure 6.1 shows a simple helicopter of this current mass. Given that the area swept out by the blades is 25 square meters and the density of air is 1.2, show that the magnitude of the lift on the helicopter is 30 v squared, where v is the speed of the air. So we first have to start with the force by the helicopter on the air. Now, remember that this is a show question, so you must show working with explanation. Now, the force by helicopter on the air will be the mass of air per unit time multiplied by the change of the velocity of the air. Okay, so the mass of air per unit time will be mass of air per unit time multiplied by the change of the velocity of the air. Right, so this V is the one we want to find. Now, what is the mass of air per unit time? This will be the volume of air, okay, multiplied by the density per unit time multiplied by delta V. So the volume of air multiplied by the density will be A L. So this is the air that is coming out, okay? So this is the length of the air column. Here's a helicopter. All right, here's a helicopter. So this is the air that's coming out of the helicopter. This is area, this is length, this is density. AL rho over T multiplied by V. But L over T is equals to V. So AL rho V squared. So substituting the equation inside, we are going to get 25 A rho V squared. So we're going to get 25 times 1.2 V squared, which is 30 V squared. Now, this is the force by the helicopter on the air. What about the force by the air on the helicopter? The lift equals to the force by the air on the helicopter. So this is equals to 30 V squared by Newton's third law. Okay, so you get 1 mark for reaching this point, A rho V squared, and then you get another mark by saying that the force on the helicopter is the same as the force on the air by Newton's third law. So most of you will miss the second mark. Now, let's take a look at Part 2, the helicopter tilts such that the lift angle is theta to the vertical. So these are the forces acting on the helicopter. This is L and this is mg, and together they will form an acceleration A. So we resolve the forces in the vertical direction first, L cos theta, and this is mg. The horizontal direction, we have L sine theta. Okay, so we see that in the vertical direction, L cos theta, it cancels the weight, but in the horizontal direction, L sine theta provides the mass with the acceleration. Okay, so given that the magnitude of the horizontal acceleration is 2 meters per second squared, calculate the magnitude of L. Now, if we take the two equations and we divide them, we get tangent theta is equals to A over G. Right, so that means that theta will be equals to arctan of the acceleration divided by 9.81. Okay, and this gives us 11.5 degrees. So if theta is 11.5 degrees, then we can use L sine theta is equals to MA. We get L sine 11.5 is equals to the mass of the helicopter, which is 4,500, multiplied by the acceleration to obtain that the lift is 45100 newtons. Okay, so this is the solution for part 2. Now you get 1 mark for each of these equations, and then you get 1 mark for the final answer. Now let's move on to the next question. A cart of mass 50 kilograms is made to move along the vertical track. Now, so calculate the minimum speed of the cart at position A, such that the cart remains on the track. Explain your working. So in order to explain your working, remember this is explain your working, so you must write statements. Let's take a look at the cart on the top. So we write at the top, okay, the normal force and mg provide the centripetal force. So we will write n plus mg, okay, equals to mv squared over r. But at minimum speed, the normal force is equals to 0. So mg equals to mv squared over r, and then v is equals to square root rg. So we can put this in the square root 15 multiplied by 9.81, and that will give us a value of 12 meters per second squared. Now, you will get 1 mark for writing that at minimum speed, n equals to 0 over here, and you get 1 mark, okay, for writing the equation mg is equal to mv squared over r, and then after that 1 mark for the answer 12. So these are how the marks are distributed. Now, state and explain how the minimum speed is calculated if the mass of the cart is decreased. So over here, we can see that v equals to square root rg gives you the minimum speed. So since the minimum speed is given by v equals square root rg, and this equation is independent of the mass, the minimum speed will not change when the mass is decreased. Now let's go to question 8. A small pendulum of mass 0.1 is given suspended by a string. The pendulum is given a small horizontal displacement of 0.012, and then is released at time t. Now, the frequency is given by this equation, so calculate the angular frequency. So what we first put in is frequency is 1 over 2 pi square root 9.81 divided by 0.4. And this one gives us that if you consider that the angular frequency is 2 pi f, this will be equals to square root of 9.81 divided by 0.4, because the 2 pi's cancel out. So this one will give us 5.0 radians per second. Some of you wrote 4.95, that is also okay. Right, so calculate the total energy of the pendulum. The total energy equation will be given by half m omega squared x naught squared. So filling in the values, that will be half. The mass is 0.1. The omega squared is 4.95 squared. And the x naught squared is 0.012 squared. So this one will give us 1.8 times 10 to the power of minus 4 joules to 2 SF. Alright, so that will be it for part B. Let's go on to part C. A sketch on the same diagram axis labeled graphs that show the following. Number 1, KE and potential energy with displacement x. So we know that one of them is going to be a smiley face, okay, with a maximum value of 1.8 times 10 to the power of minus 4. And then also we know that the displacements at the maximum and minimum displacement is 0.012 meters and negative 0.012 meters. The total energy will be constant. So this will be where the total energy is. Okay. Right. So another thing that we need to mark out is half the total energy over here. So the other graph will look like this. We'll pass through all 3 points. Okay. And down again. So remember to mark this point over here. This will be your potential energy, GPE. Okay. And then this point, this graph over here will be your KE graph. So this will give you 2 marks once all the values are labeled. So we have come to the end of our WA review. If you have any questions, please let me know.